Hello folks and welcome. Today I want to talk about exponents and some related topics. So please get yourself some lined paper to work on. You'll need the lines today. And let's get started. Okay, so follow along with me here on this little path. You don't have to write this down initially, but follow along. If I did say 2 plus 3, you know that that's 5. If I said 2 plus 2, that of course is 4. If I said 2 plus 2 plus 2, you could easily grasp that that was 6. What if I said 2 plus 2 plus 2 plus 2 plus 2? It wouldn't take you long to figure out that that would be 10. But my question is this: did you add or did you do something else? Because if you repeatedly add the same thing over and over and over again, it would be the same thing as saying 2 times 5. That's also equal to 10. And I'll put a circle around the X there so you know that it's not a variable. I actually mean the operation. So repeated addition is multiplication. The one number tells us what we're adding. That would be the 2. And then the 5 tells us how many 2's we have. Okay? Now, let's take it to the next level. What if I said 2 times 3? I might even use parentheses instead of an X. So 2 times 3, that would be 6. How about 2 times 2? Of course, that's 4. How about 2 times 2 times 2? Yeah, that would be 8. Do you see where I'm going with this? How about 2 times 2 times 2 times 2 times 2? It might take you a while, but you could come to the conclusion that that would be 32. But if I repeatedly multiply, is there a better way to do that? Just like if I had repeatedly added, we said that that was multiplication. And hopefully you realize, yes, that would be equal to 2 raised to the 5th. So what I want to talk about today then is exponents. So now's a good time to start taking notes. Exponents would be repeated multiplication of the base. And so the first thing that we want to do is we want to identify the terms. So leave a little space here, but the most common one that I could think of that would be helpful to use as an example would be 3 squared. You of course know that that's 9, okay? But let's be deliberate now about what the terms are. We need to know what to call these things. The 3 is the base. The 2 is called the exponent. What's the 9 called? What do you call the answer to an exponent? Can't just say the answer. There's got to be a special name for it. We had special names for the other things. What do you call an answer to an addition problem? That would be a sum. And so even down here, if I solved this one by adding, that would be a sum. But if I solved it by multiplication, it's called something else. What do you call the answer to a multiplication problem? That's a product. When you subtract, the answer is called a difference. When you divide, the answer is called a quotient. So what do you call the answer to an exponent? Lots of folks don't know this, and it took me a while to get to the answer. I actually had a conversation one time. We were having dinner, a group of us, with a professor with a PhD in mathematics, and I made sure I sat next to him so I could ask him this question. So what do you call the answer to an exponent? Because we got all these other things. And he said, I don't know. And I was like, great. So if the PhD in math doesn't know what it is, like there's no hope for me. But finally, in an old book, I came across what the answer was. There is a name for this thing. It's become confused, I think, recently. But anyway, the answer to an exponent is the power. Now you're saying, wait a minute, I've called this the power. No, that's the exponent. And there's a bit of sloppiness, I think, in language about the exponent and the power. Some might even say that, well, the power is not the exponent itself, it's the expression of the base to the exponent. That's the power. Okay, but isn't that 9 in this case? Right? The funny thing is, about 7 or 8 years later, I ran into that same professor again in a different place, different time. He even looked different. He had cut his hair and was in a suit. Before, he had a ponytail and he was in like a Hawaiian shirt. And it took me a second to figure out who it was. I said, oh, do you remember me and this question I asked? And he said, yes, that was a very annoying question, because he didn't know what the answer was. I said, I found it. It was in an old book. It's called The Power. And he thought about it for a bit, and we talked for a bit. He goes, no, you're right. The reason we need a separate name for this is because we're going to start to rearrange these things, and we have to know what we're talking about. So to be even more clear, the base is the thing that is repeatedly multiplied. The exponent, and this is crucial as well, is how many bases. I remember being in 6th grade when we first learned about these things, and we were allowed to use a calculator to do exponents. And the way that it was explained to me, or what I understood in my mind, which may not have been the same thing, but the way I understood it in my mind was if I had 4 raised to the exponent of 3, the 3 meant how many times I multiplied 4. So 4 cubed meant multiply 4 by itself 3 times. Okay, so we were allowed to use a calculator, and it wasn't a scientific one. It was just a normal one. But I went 4 times 4. That's 1 multiply. I pressed the multiply button once, and I have to do it 3 times. So then times 4 again. That was pressing the multiplication button twice. And then I said times 4 again, and I got the wrong answer. And there was a bit of confusion. When you do 4 raised to the exponent of 3, you have 3 4s. 4 times 4 times 4, but you only have 2 multiplies. Okay, so it's not how many times you multiply 4, because that means you have 3 multiplies. No, it's how many bases, right? So the exponent means how many bases that you have. Okay, so be careful with your thought process on that. All right, so now we've established that 3 squared is equal to 9. Let's talk about a slightly different situation. What if I had negative 3 squared? What's that equal to? The way I have it written right there, it's equal to negative 9. And some of you are going to be a little confused about that. You're like, no, wait a second, isn't it still the same thing? No, and the question that you're thinking about really is, what's the base? Okay, the answer to an exponent is the power, but when you see an exponent, you've got to be thinking about what's the base. What is the thing that's going to be repeatedly multiplied? And the way I have written it here, the exponent only applies to the 3. If I wanted to include the negative with it, I would have had to have put a group around it. Negative 3 squared, that's equal to positive 9. Okay, and let's talk about why deliberately and thoughtfully. An exponent means repeated multiplication, but what's the base? The way I have it written here is only the 3. Okay, because the negative is not part of the package. It's not in the parentheses, because the parentheses shows you what's in the package. What this means is a negative of, but only the 3 is repeatedly multiplied. And as you can see, that's negative 9. But when I include the negative sign in the parentheses, this means the base is now -3. And so then it's -3 times -3, which is +9. Okay, so be very careful of the base. The thing that you should be thinking about when you see an exponent is, what's the base? If there are no parentheses, it is only the thing that the exponent is touching. It's only the character or the symbol or whatever it is that you're talking about that's immediately to the left of the exponent and nothing more. So, for example, if we did this algebraically, 7x quantity squared means that the base is -7, which means I repeatedly multiply 7x times 7x, and I get a positive 49x squared, which, if you think about it, is simply just squaring each of these pieces, right? Isn't that 7 squared x squared? Isn't that what I get? Yes. But what if I did, say, 7x squared with no parentheses? What does that simplify to? Well, it's just the same thing, 7x squared. Because it's only the x that's being squared, and I don't know what that number is yet. Maybe I would later on. Okay, so be thinking about what the base is. Let's go ahead and say, what if I said I've got 7x squared, and I'm going to let x equal -2. So the way I want you to do this is maybe put parentheses around the thing that's being squared to begin with. It's that, just your single variable. And then what you should do is you should write 7 open parentheses, the square outside the parenthesis, and now we're going to evaluate by plugging in -2 for x, so -2. Now, when I've written it like that, it should be very clear what the order of operations are and how I should solve this. I've got to do the exponent first, so it's going to be -2 times -2, 7 times +4, final answer 28. That's the right answer. I've seen students do this though. Instead of writing it like this, they write it as like 7 times with a dot, and then they'll put in -2, and then they'll say squared. And that's terrible structure. Number one, you should always be using a parenthesis for multiply, not a dot, especially if you've got something more than just a single base. In this case, it's -2. So I would be overlooking that -2 is part of the base, and I would also be maybe overlooking that it's the quantity squared. So anyway, this is the structure that you should use when you're going to evaluate. All right, now let's try one that, well, I won't say anything. I'll just give it to you. How about x plus 3 quantity squared? Why don't you take a moment real quick and just write down what you think your answer for that is. Just real quick. If you wrote x squared plus 9, hang on a second here. No, absolutely not. It is not x squared plus 9. And some of you are a little confused right now, which is good because you're thinking deeper than maybe you were a moment ago. No, it's not x squared plus 9. You do not simply square each of the pieces and you're going to say, Mr. Marsh, like, why not? We just did that a minute ago. It was different. But before we clarify that, let's talk about what does squared mean. Square means repeated multiplication. So in this case, I've got what's the base? The base is x plus 3. So let me go ahead and just take the time to write it out. What does it mean? It means x plus 3 times x plus 3. And now if I kind of like only let you see that, how would you do this? Oh, well, you know how to do this. You would FOIL this. I would take the x times the x and call it x squared. And then I would take x times the 3, so that would be plus 3x. And then I would do this one, so that's plus 3x again. And then 3 plus 3, that would be positive 9, right? Remember the first and the outer and the inner and the last and so forth like that? So when I simplify this, I'm going to get x squared plus 6x plus 9. That's the proper way that you square a binomial. It is not just x squared plus 9. So you're missing that middle term. But what's the difference? Okay. Remember I told you the question is what's the base? When it was up here and we were doing 7x squared, I did just square each of the things in there. Why is that? Because it's already multiplied, right? Isn't that 7 times x? And doesn't square mean repeated multiplication? So if you're repeatedly multiplying something that's already multiplying, you can just simply square each of the little elements that's there, multiplying. It's a monomial. It's only one term. There's no pluses or minuses in there. And that's what the problem is here on this one. An exponent does not mean repeated addition. It means repeated multiplication. So unless that's multiplication in there, which it isn't, you can't just simply square each piece. Okay, this is a binomial. This is 2 terms. And so it's different. But if you write it out as repeated multiplication, you should always be able to see what it is. Now, there is like a little special multiplication formula or pattern for this, but I don't want to get into that right now. But anyway, be mindful of simply squaring the pieces of something added or subtracted. You can't just do that. You've got to actually multiply it out. Okay? All right, so by way of review, if we do something like 3 squared is equal to 9, what I've got is I've got the base raised to the exponent. It's a superscript. It's written above. Okay, and that is equal to the power. The answer to an exponent is the power. What would I do if I were to like maybe change those things around? What if I said I wanted to take 9 and I wanted the answer to be somehow 3? How would I do that involving a 2? Because see, look, I've got one element of 3, one element of 2, and one element of a 9. Let me rearrange them. How do I make 3 the answer? By doing something with 9, and I have to have something going on then with 2. How would you do that? In other words, if 3 squared is 9 and I wanted to go backwards and start with 9 and wind up with 3, how would I undo that? Hopefully you understand that it would be a square root. Square root of 9 is equal to 3. You're going to say, yes, but where's the 2? It's right there. But you normally don't write it. The exponent kind of goes up in that little notch right there. But if it's an exponent of 2, you just kind of leave it blank. That's why it's called the square root. Okay? Maybe you've seen problems where you had the cube root of something. And you do have to write the 3 in there. Anything other than 2, and you have to write it in there, because if you don't write anything, it's understood to be 2. Kind of like the exponent on x to the first power. You don't write x to the first, you just write x. Okay? So, if that's the case, doesn't that mean this? Doesn't that mean that I've got the square root symbol, and what has gone inside? The 9 went from the answer on this part to the kind of part of the question on this part. But what was 9? It was the power. So what goes under the square root symbol? It's the power that goes under the square root symbol. And the 2 was the exponent. Where does the 2 go here? It goes in the crook. So this then would be the exponent right there. And then the answer is the base. Okay? So here's the setup if you're doing a root. And you will never see that in a textbook, or at least I've never seen that format written in the textbook. But it makes total sense to me, because if I've got this arrangement, it naturally follows that I've got then the one below it when I rearrange those pieces. What you'll see in a textbook looks like this. You'll see the symbol, and then the textbooks will call what's inside, they'll call it the radicand. Not radicant, radicand with a D as in delta. And then they call the thing up there, they call that the index. And then like, I've never seen them even say what that is over there, okay? I don't know why they change the names of those things. In fact, I'm not kidding, just the other day, while I was putting this together, I went over to two different math teachers that are here that work with me. And I was like, just follow me on this. Am I thinking rightly about that? Is that what this really is? And both of them were like, why are you calling it this and that? And I'm like, well, isn't that what it is? And so there was a little bit of a math debate because they wanted to initially say that that was wrong. That the power goes, what's the power? We had that debate whether we could call 9 the power or not. But the power goes under here. It's not the power, it's the radicand. I said, it's the same thing. It's not the exponents, it's the index. It's the same thing, right? It's the same thing. And so, I don't know. I think sometimes we use different words to mean the same thing, and then sometimes when we do that, we are unaware that it's the same thing because we're using different words. But I'm fairly confident that that's the situation there. But you won't see that in the book. You'll see it called the index and the radicand. But it's really a power and an exponent. Okay, so let's talk about now what a root, which is what we're talking about. We're not talking about roots. We're not talking about exponents. Let's talk about what a root is. Basically, it's asking you what's the base. Okay, the answer to this is what's the base. So if I said, what is the square root of 25? What I'm really asking is what squared is equal to 25? And of course, you should know that the answer to that is, oh, I know what that is. That's 5, right? Because 5 squared is 25. If I said the square root of 81, you're going to say, well, that's 9. Of course it is, because 9 squared is equal to 81. See, it's asking you for the base. It's asking you for the beginning thing of the exponent, which I think is why it's called a root. Like the root of a tree is where it comes from. Same idea there. Now, that's why this is a problem. Square root of negative 36. You should know that that's not allowed. You cannot take the square root of a negative number. But why? What question is a root asking? It's asking me, what's the base that when I square it, I get negative 36? What squared is negative 36? Well, you can't tell me it's 6 because 6 squared is equal to 6 times 6, which is equal to positive 36. And believe it or not, you can't even tell me negative 6 works because negative 6 squared, remember the negative is part of the base, that's going to be negative 6 times negative 6. And a negative times a negative is a positive. That's also positive 36. So there's nothing in here. This does not exist. DNE. That's why you can't take the square root of a negative number, because nothing squared turns out to be negative. Now, you can square something and make it positive. Look, you can do a cube root of a negative. That's possible. If I said the cube root of negative 8, what is that? Well, this is asking me then again, what cubed is equal to negative 8? That should be negative 2. Look, because it's negative 2 times negative 2 times negative 2. And a negative times a negative times a negative is a negative. That's negative 8. That works. Okay, but you can't take the square root of a negative number. Let's see here. What else do I want to talk about? I was going to talk about maybe some algebra stuff. Let me do a simple thing with algebra. What if I wanted to do the square root of, let's see here. How about 16x to the, I'll make it an even number, 6. Okay, how would you do that? What it's asking here is it's really asking what squared is equal to 16x to the 6th. Hopefully easily you can do the number, right? The square root of 16, that would be 4. But what about the variable? It's going to be x to the something. What something goes here that when I square it gives me 6? Now you may have kind of an instinct for it, and that would make it 3. So the answer here is going to be 4x cubed. But how would you do it, like, I don't know, analytically, if you didn't know the pieces? One of the ways to do it is to break everything down into prime factorization. I'll show you kind of a long way. It takes time, but it's very, very simple. 16, if I break it down into primes, it's going to be 2 times 2 times 2 times 2, and then I got to do the x's. 1, 2, 3, 4, 5, 6. I should have picked smaller numbers. Okay. What's the index? Well, the index out here is also 2. What does that mean? It means I'm looking for bases that are grouped by 2's of the same thing. Got to be the same thing, right? So here's a group of 2. Here's also another group of 2. And then here's a group of 2, and then here's a group of 2, and then here's a group of 2. So everything's in a group of 2. And so my base that comes out here is going to be 2 as the base when it simplifies. Now, how many groups of 2 do I have? Do you see I've got one group, I've got 2 groups, and so that's my exponent that comes out. Okay, what's my other base? Well, I've got bases here of x, so that comes out. Now, how many groups of 2 do I have? I have one group of 2, 2 groups of 2, 3 groups of 2. There we go. That's one way to do it. There are alternate methods or so forth. This one, I think, gets it down into its basic kind of a long but simple sort of thing. So a root is asking you now, what's the base? And so by way of quick review, we're going to have, we're going to have 3 squared is equal to 9. That corresponds with, in language, the base raised to the exponent is equal to the power. And then after that, we've got the square root of 9 is equal to 3, and maybe like a little phantom 2 written in there, because normally you don't write it, but I want you to be aware that it's there. Okay, that corresponds into the radical symbol with the power inside and the exponent outside, and the answer is the base. But there should be one more, right? Don't we have 3 different elements running around? The base, the exponent, and the power? So I've got the first question, which the answer to it is the power. I've got the next question, and the answer to it is the base. So I should have one more thing where the answer is the exponent. How do I do something with the numbers of 3 and 9 so that the answer is 2? I don't divide. I don't multiply. It's got to be something else. If you were like me, I learned exponents and roots probably 6th or 7th grade or so. That was when that was introduced. This third thing here that I'm about to share with you doesn't usually get introduced until Algebra 2 in high school. I don't know why. I had a student today who was from Canada, and she said, oh no, we learned about it in Canada like years ago. I was like, we're doing something right up there in Canada, because I think we should learn about all of these pretty close together, okay? It's a logarithm. Log base 3 of 9 is equal to 2. Ta-da! Okay, logarithm. Logarithm. An exponent asks what's the power. A root asks what's the base. A logarithm asks what's the exponent. And in fact, I got a poster on the wall. I'm looking at it right now. It says logarithm asks what's the exponent. Okay, so it looks like this if we're going to spell it out in words. Log, and then the base is written as a subscript. That's why I wanted you to have lined paper. It needs to be written below the line. And then I always use parentheses to contain my power. Some books don't, and then it gets confusing as to what's your base and what's your power and what may be coming afterwards. I need that group. And then the answer is the exponent. Okay, This is kind of like the little Trinitarian thing of exponents, bases, and powers. Okay, 3 different arrangements for 3 different types of considerations. So let me give you just kind of like a little discussion of it. So let's practice a couple here. So if I said log base 5 of 25, what is that? And let me be real specific now. Let me spell it out as I'm going through it. Logarithm asks, what's the exponent? So really this says, what's the exponent on 5 that gives me 25? And that exponent is 2. Get it? Log base 2 of 8 is equal to what? Well, what does it mean? What's the exponent? Because every time you see the word log, you should be translating what's the exponent. Okay. What's the exponent on 2 that gives me 8? 3, right? Because isn't 2 cubed is equal to 8? Okay, it's asking for this right here. How about log base 9 of 1? You might even want to write it as an exponent. What is the exponent on 9 that gives me 1? 9 to what exponent up there? I circled the space where the exponent's going to be written, but actually, maybe that is the exponent. Yes, 9 to the 0, right? 0. What exponent? 0. There we go. Okay. Let's see what else. Oh, let's do log base 7 of 7. Oh my goodness, that's so terrible. That's hard. It's asking me what's the exponent on 7 that gives me 7. 7 to the what up here is equal to the 7. 1. Right? Isn't it 1? The answer is 1? That's a little too close. It's not 17. Yeah, because 7 to the first is equal to 7. All right. Now, log base 5 of negative 25. What does that mean? That means 5 to what exponent is equal to negative 25? Oh, we're back to this issue again. You remember this issue with the square root? Okay, this does not exist. There is no exponent up here, none. There is no exponent you can put on positive 5 that makes it a negative 25. And that's one of the rules of logarithms that I haven't mentioned yet, is your base has to be positive. So it's always a positive down here. You're never going to have a negative base, not allowed. That creates problems that make it impossible to do logarithms with. Okay, so you cannot take the logarithm of a negative number. There is no exponent on a positive base that gives you a negative power. So you can't take the logarithm of a negative number. You can't even take the logarithm of 0. So if I said log base, I don't know, 4 of 0, that's asking me 4 to the what is equal to 0. That doesn't exist either. It does not exist. Okay? So we got our 3 little groupings here. Exponent asks what's the power, a root asks what's the base, and a logarithm asks what's the exponent. I think all 3 of those things ought to be taught at the same time. They go well together. It's just 3 different expressions of the same kind of little family of math properties. So anyway, may your day be merry and bright, and may all your mathematics be right. How do you know if it's right or not, though? That's mathematics.